Hey guys, so today we're going to be going over the Fundamental Theorem of Calculus. This is pretty important for solving integrals. This is the second part. The first part is pretty simple, so I won't go over that today. It's basically just saying the derivative of an integral gives you the original function, but I feel like that's pretty obvious, alright? So first, this is the Fundamental Theorem of Calculus. So the integral from a to b of f of x dx equals f of b minus f of a, where the f's are the integral of f of x. So, kind of more intuitively, integrals is the area under a curve. All right. So, for this example, let's just say this is f of x. All right, and this is b and this is a. So, integrals just give me this blue area under here, right? So, if I take the area from b minus a, I get this whole thing. All right. So that's basically what FTOC, Fundamental Theorem of Calculus, says. So you're basically taking the integral and subtracting the upper bound, and then you're subtracting the bottom bound. Alright? So let's do some practice questions so you guys get a little bit more familiar. So we get integral 1 to 4 of 3x squared dx. I don't know why that dx looks... I don't know why it looks like that. Alright, so first, let me just try to integrate 3x squared. So 3x squared, the integral of that is just 3x cubed over 3. I'll just cancel this out. So it's just x cubed. Now, x cubed, this is the proper notation. A lot of people write it different, but I like to write it like this, here, and then you put the 4, and then you put the 1. Now, first step, you take the top bound and you plug it in to your into the x cubed. So it's going to be 4 cubed minus, then you take the bottom bound, 1, and then you plug it into the x cubed. So it's going to be 1 cubed. So it's 4 cubed minus 1 cubed. So 4 cubed is just 64 minus 1 cubed is 1. So then we get 63. So what does this mean? Basically, in the graph of, here, let me just draw it. 3x squared, so it's going to look something like this. From 1 to 4, right, this area right here is 3. Is 63, sorry. That's basically what this equation gives you. So that's basically what FTOC is. So next question. Alright, here's a little bit longer one. So the integral from negative 2 to 3 of 2x squared minus x plus 5 dx. Alright, so same thing. Let's integrate it. So it'd be 2x cubed over 3 minus x squared over 2 plus 5x. And remember, you can't forget your bounds. And by the way, you don't use your constant of integration because this is a specific area under the curve. So you don't need that extra constant of integration for these types of integrals. And these types of integrals are called definite integrals. The ones that you've seen so far in your math class are called indefinite, where there are no bounds, but these ones are called definite. So anyway, so you put your negative 2 at the bottom and 3 at the top, nothing changes. And now we're going to plug in our 3 and our negative 2. So it's going to be 2, 3 cubed over 3 minus 3 squared over 2 plus 5 times 3 minus, and this is where a lot of people mess up, parentheses 2 negative 2 cubed over 3 minus x squared over, oops, not x squared, we know that's 2. So it's negative 2 squared over 2 plus 5 times negative 2. So when you simplify this all down, you're going to get 55 if you use your calculator. So again, what does that mean? What does this 55 even represent? Well, this 55 is basically just, if I graph 2x squared minus x plus 5, whatever that looks like, let's say something like this, I don't know. No, it's not going to look, I don't know, something like this, okay? From negative 2 to 3, this area in red is going to add up to be 55. All right. So, next question. So, this one is a little bit tricky because you see we have the bigger number on the bottom. And you guys will see kind of the relationship that there is. But let's do the same steps. Integral of x squared plus 1. So, integral of x squared is just x cubed over 3. Integral of 1 is just x from 2 to 5. So now we plug in our numbers. So it's going to be 2 cubed over 3 plus 2, all right, minus 5 cubed over 3 plus 5. So, what does this equal? Well, if you use your calculator, you're going to get negative 42. All right, so now, you guys might be wondering, why is this negative? Well, think about it like this. Yes, integrals are the area under a curve. All right, so this is the area under a curve, but let's go like this, all right? So this is the area under the curve, but pretend it's like a signed area. So this area right here is a positive, but this area right here, since it's underneath the x-axis, it's going to be negative. So pretend like you're walking underground. So really, let's call this area A and this area B. So the total area is just going to be A minus B. All right? So this is why it comes out negative. But interestingly enough, if you flip the bound, so if you go from, if instead, let me cross this out, you go 2 to 5, you're actually going to get 40 plus 42. So if you flip the bounds, you take the negative of whatever you got. All right, but anyway, let's move on to our next question. And this is a kind of like a word problem, a common one you'll see. So a water tank is being filled and the rate of water flow into the tank in liters per minute is given by 12t minus t squared plus 5, where t is the time in minutes. How much total water flows into the tank during the first 6 minutes? Okay, so the best way to think about this problem is to think about it like this. A rate tells you how fast something is changing at each moment. All right? The integral adds up all those tiny changes over an interval, and when you add up all those small changes, you get the total change. So that's the whole idea behind this question. So what does that mean? So if I take dx of integral f of x dx, this is just going to be f of x. I'm just left with the original function. Okay? So so if I take the integral of the rate of water flow, I end up with the total water. So all I have to do is take the integral of 12t minus t squared plus 5, 12t minus t squared plus 5. But now I have to figure out what are my bounds. Well, it's asking how much water is in the tank during the first 6 minutes. So I have to figure out, so pretend this is the graph. I have to figure out how much water is going into the tank from 0 to 6, right? So it's this area right here. So my bounds are going to be 0 to 6. So now let's, dt, sorry, you need to keep that there. So let's integrate t squared over 2 minus t cubed over 3 plus 5t from 6 to 0. And now you guys can use a calculator for this. You get 174 liters, and that's your answer. So I hope this video helped. Obviously, we're going to go a lot more in depth once you guys practice these, but this is kind of the basics of ftoc. I hope you guys enjoyed the video. If you did, please subscribe and like, and I'll see you guys in the next one.